All right, so welcome back to your favorite inorganic tutor YouTube channel once again. Today is another episode, and we are going to look at how we can tackle this particular problem on the board right here. But before I begin, let me give a very big shout out to Mr. Rad. All right, he is the man who actually told me to begin this initiative, and it has been of great help to many out there and to myself as well. The next shout out to my own brother Enoch for making sure that he gives me the necessary funds and then items to make sure that I elevate this channel to the highest premium. And the next shout out to Isaac Konab, big ups, big man. Um, the next shout out to everyone out there who always makes sure that he taps or she taps on my content to watch, to share, comment, like, and then subscribe as well. May God bless everyone out there massively. And let me not forget, Merry Christmas in advance to you all. Enjoy with care. Don't forget that as you enjoy your Christmas, then you press on my content to watch, to keep yourself um, informed of whatever is going on in the world. Because if you stop learning, you are dead. That's it. For every man, you don't have to stop learning, and that will make you human being, right? So let's try to look at this how we can tackle this particular problem on the board. This right there is a limit, and we have to make sure that we solve this with gentle process. But looking at this challenge on the board, we can't use our normal way of solving limits. We have to set up the squeeze theorem, or what we call the sandwich theorem. So this right here, we have to use the sandwich theorem or the squeeze theorem. The squeeze theorem, what it intends doing is that when you have a function and you can't evaluate that particular function easily, then you apply the sandwich or the squeeze theorem. Right, so this right here, we have to set up the squeeze theorem, right? So this is what the squeeze theorem says, right? So when you have a function, right, and then that particular function, you cannot evaluate it so easily, then you find the limit of the function at the lower end and that of the function at the upper end. If provided their limits are the same, those at the lower and the upper end, their limits are the same, then you can conclude that the limit at the middle is also having the same limit. So right here, let's look at how we can do this. So we know that, of course, sign oscillates between -1 and +1, right? So we set up -1 less than or equal to sign, of course, is sign into 5 on x, right? Less than or equal to +1, right? So what we have to do is that we have to manipulate this function to make sure that we have the middle term having the same feature as the function provided here. So what we do is that we first multiply through by s power 6. So we have here x power 6 times -1 is, of course, negative s power 6 less than or equal to s power 6 sine into 5 on x less than or equal to s power 6, right? Then we have to do what we call limit application. So we apply, now that we have the same function as possessed here, then we apply what we call the limits to all the items, right? So when we do that, it means we are going to have lim as s approaches 0 right here, negative x power 6 less than or equal to limit as s approaches 0 sine, or let's bring the s power 6 first, less than or equal to lim as s approaches 0 s power 6, right? We all know that when you substitute 0 in here, we are going to have 0, right? Less than or equal to lim as s approaches 0 s power 6 This right here, so of course, is 0, right? So when we do this, we can see that the limit right here is equal to the limit right here. So we can conclude that this limit right here is also equal to 0, because you know that when you have one guy here in the middle here, there is another guy up at the upper end, there is another guy too at the lower end. And these two guys at the lower and the upper, they are squeezing this guy in the middle. So provided this guy and this guy, their limits are the same, then we can conclude that this guy in the middle also have the same limit as these two guys at the lower and the upper end. So that's it for this question right here. So we have here limit as s approaches 0, s power 6 sine into 5 on x, and that should be equal to 0. So we have realized that the guy over here and the guy over here have the same limit. Therefore, we can conclude that the limit of this guy is also 0.